Good morning, ladies and gentlemen. What I will be discussing tonight will be how to measure alternating current voltage by using a multitester and by using an oscilloscope. Okay. To show you the how to measure AC voltage by using a multitester and oscilloscope, I got here an AC transformer, a small transformer. The output of this one is alternating current. It's not a direct current. So this is just a plain transformer without any diode inside. So the output of this one is actually alternating current. The output terminals are actually this one. Okay, this came from the transformer. And I bring out my multitester and I set this one to the voltage AC range. Okay, the terminals now for the red and black, there is no polarity here. We could interchange the location of the red and black. For alternating current, it doesn't matter. So what comes out here is the alternating current voltage or the RMS value of the reading on the tester. RMS value meaning root mean square value is 11.43 volts. So what I will be doing next is actually to measure this 11.43 approximately by using the oscilloscope. So I powered up my oscilloscope. I bring out the cord that came from the oscilloscope and I connected the ground terminal and the signal terminal on the oscilloscope. It's connected already. Okay? So there will be a graph that will be coming out on the oscilloscope since it is already connected to the output terminal of the transformer. Like what I said, the reading is 11.43 volts AC. So how do we know if the reading that comes out on the oscilloscope is 11.23? So the first thing that we will do is actually to put the signal terminal on the AC. We adjust the volts per division of this one. So we adjust it. So we could see the graph, not too small, not too big. It is just good enough that it will fit up on the screen. So we could choose a setting here. If I will try to listen the volts per division, you could not see the graph, right? So I will bring back to the original toggling of the volts per division. Okay. So we could see it on the oscilloscope. Because if I put it on the small volts per division, it will become very big and some of the graph is actually not on the screens. So we must have to choose the setting of this volts per division so that the graph will be exactly at the center of the oscilloscope. So when we are measuring voltage, we could see the volts per division accurately. Okay? And one thing more, the setting, if I place this setting here, there is a toggling setting over here, either times 1 or times 10. If I will put it on the times 1, okay, the graph is very big, times 1. So I will place this one, I will make the graph smaller, so I will toggle this one to the times 10. Okay, so meaning to say, this graph here was less than 10 times than the original. So in the computation of the voltage, we should multiply it by 10. Okay? Okay, let's now try to count the so-called peak-to-peak voltage. Peak-to-peak meaning from the highest point to the lowest point, we will measure how many divisions will that be. Okay? And as I could see it, what will be the volts per division in this one? I place it on the 5 volts per division. Okay, I make the graph smaller so we could see the accurate reading on the oscilloscope. The lowest point is this one here. That's the lowest point. And this is the highest point. And from the highest point to the lowest point, I could see it's around 1.6. 1.6 divisions. Okay, that's peak to peak. So if I will try to bring out the computation of this one, the peak to peak reading will be, I counted 1.6 divisions. The volts per division is actually times 2. Okay, times 2. And I place a multiplier times 10 because I set this one to times 10. Okay, so 1.6 times 2 times 10, that will be 1.6 times 2 is 3.2 times 10. That will be voltage peak to peak is 32 volts. And if we will take 1/2 of that one, voltage peak meaning from the center line, from the horizontal line to the maximum or negative point, that will be 1/2. Lowest point from the middle thing is actually 1/2, right? So if we try to get the middle thing, the value will be 1/2 of 32, and that will be 16 volts. And this 16 volts is the one needed in the computation of the RMS voltage. If you try to Google the relation between the voltage peak, that's the 1/2 value, from the center line to either the highest point or lowest point. The relation between the RMS and the peak voltage is actually 0.707 times the peak voltage. This peak voltage is around 16 volts. We could not get the actual something point value, so we will approximate it to be 16 volts. So like what I said, we try to Google the relation between the RMS and the peak voltage. Is given by 0.707 times the value of peak voltage. So 0.707 times 16, and what comes out is 11.3 volts. Meaning to say, by using the oscilloscope, the reading is 11.3, and by using the multitester, it's around 11.48. We cannot include the other decimal places over here because on the oscilloscope, it's not so accurate. We are just getting the approximate value. So by using the oscilloscope, like what I said, it's 11.3, and by using the multitester, it's 11.49 or 0.5. There's a difference around less than 0.2. So that's how we measure AC voltage RMS value by using the oscilloscope. Make it a point that the graph on the oscilloscope will not be coming out from the on the screen, because if I will try to listen the volts per division, the graph will become very big. See, it's very big already. So choose the volts per division such that the graph will be inside the screen. So you could count how many divisions maybe from the negative maximum to the positive maximum. Okay, we could measure from negative maximum to positive maximum, then from the center line to the positive maximum and minimum, that will be 1/2. That's why in the computation there is 1/2 over here. And the relation between RMS, the multitester reading, supposed to be, is actually 0.707 times the value B peak, meaning from center line to the positive maximum or from center line to the negative maximum. And if we try to multiply, like what I said, if you try to Google RMS and voltage peak relation is given by this 0.707 times BP, peak value. Okay, the 1/2 value of the peak to peak. And if we try to compute, it's 11.3. And what comes out on the multitester is 11.3. It's not so far, but at least when you are troubleshooting, at least you know that the correct AC voltage is almost the same as the reading on the multitester. Okay, good evening, good morning from Los Angeles. This is Professor David J. De Los Reyes. What I discuss is the way and how to measure AC voltage by using a multitester, and the way how to measure or get the approximate value of that RMS value by using a oscilloscope or an oscilloscope. Good morning from Los Angeles.